Hello and welcome to Module 9, the transport layer. So at this module, we will cover TCP and UDP protocol because those are the main two protocols that operate in the transport layer, and you'll understand the responsibility of the transport layer and what does it do in terms of the encapsulation of the data that it receives from the application layer. All right, so don't forget, we will take notes as we move along. So I'll ask you to take notes, and you write them in the Microsoft Word, and then you'll submit them as proof. So we will cover the characteristics, the session establishment, and when we say the transport layer is a reliable, well, in terms of TCP specifically, a reliable transportation of the data. Okay, so the main responsibility of the transport layer is for logical communications between applications running on the different hosts. So its main responsibility is encapsulating the data that it receives from the application layer. All right, so either send it to TCP or UDP, and then the transport layer will segment that data and place a port number to identify what application that it has encapsulated into these segments. So write the first bullet point. That's really the main responsibility of the transport layer, is to encapsulate the application layer and identify it by placing a port number on there. All right, so how do we track them? Like I said, by placing a port number. So the first thing that the application layer, after it gets its data, depending on what type of application you are using, you either give it to TCP or UDP. And the first thing you do is they break up the data into smaller segments. And on each segment, they put the TCP will put sequence numbers on them, and then we'll put a port number, a well-known port number to identify what type of data is in there. For example, if it is port number 25, that means the data is an email data for SMTP server. If it's port 80, then it's an HTTP server, HTTP data, and so on. So the port numbers identify what applications are there. All right, and then when you segment, so it makes it a little bit easier. So when you segment them, you cut them into the smaller pieces. We call these our segments. So data at the transport layer is called segments. You have to put a sequence number on each of those segments. Let's say the whole data is broken into 10 segments. You have to identify sequence number 1, 2, 3, 4, 5, 6 on each of the segments, so that when the data gets to the destination, you'll be able to reassemble the data. That's why we need sequence numbers. All right, so write the first two bullet points right here. So the other responsibility, other than identifying what type of application data is encapsulated in the segments by using port number, the other thing that the transport layer does is, especially the TCP protocol, will place sequence numbers on each of those segments. And those sequence numbers identify what type of, well, not identify, those sequence numbers are used so that the destination is able to reassemble the data. All right, write the first two bullet points here. Of course, it does all of that by taking the data and adding headers to it. So when I say stamping port numbers or sequence numbers, you put that in the headers. And now you're getting your segment. That's what encapsulation means. You put the data in and you put headers on it. All right, so as we've discussed earlier, just now, port 80 will identify that this is a web page. Port 110, this is for the to grab data from a post office server, and so on. So each application has a unique port number, a well-known number, right? You should be familiar with those. And all of the segments now are multiplexed. Multiplexing means you can place all the data on the same wire so that they can travel together, but they are identified by their sequence numbers, which one comes first, which one second, and also by its port number. So they all can travel at the same wire because they are all unique because of their port numbers that are stamped on them. All right, so this is a very, very important screenshot that you should take. So you have these protocols at the application layer. So all of these applications, they give their data to TCP. DNS, if it's internal, it will use UDP, just like TFTP. If it's external, it will use TCP. So just to, as a rule of thumb, if your data is going outside your LAN, you need to use TCP to transport your data. If it's internal, you probably would use the user datagram protocol because it's quicker and it's connectionless and it's not reliable, UDP that is. But transmission control protocol, it's reliable, connection oriented, and it controls the flow of the data. That's why we call it transmission control. Once the segments are done and it has the sequence numbers on them, by the way, UDP doesn't put sequence numbers, just TCP does. Once the ports numbers are done and the segments are done, both of them will pass those segments to the IP protocol, and the IP protocol encapsulates these segments into packets, and then we put the IP addresses on them. And those packets with the source and the destination IP address on them are placed either it's given to the network, the NIC, and the NIC will place those packets into a frame, and then the frame will have the MAC addresses, the source and the destination MAC address, so they can travel on the wire, either inside a LAN with Ethernet or outside, maybe using a point-to-point connection, PPP. All right? So TCP, the Transmission Control Protocol, it is considered, right, the first bullet point, it's considered to be reliable. That means it's going to make sure that the data has reached the destination successfully, and if not, it will ask the source to retransmit. All the fields will ensure the delivery of the data, blah, blah, okay. Okay, so just write the first bullet point. That's what reliable means. It's going to make sure that the data has been received successfully, not corrupted. If in any way it finds out that it's corrupted, it's going to re-ask the source to resend the data. That might slow things down a little bit. So when you are downloading a file, it might take a little while if there's traffic and there's a lot of packets that have segments that got lost on the way or got corrupted, you're transmitting, so it takes a little while. So that's why sometimes if you're downloading a file, it may take longer to download it. If you're downloading it, let's say at 2 o'clock in the morning when there is really no traffic. So 2 o'clock in the morning, you'll download it much quicker. But it's guaranteed that the file will be successful once it's finished. Once the whole thing is downloaded, then you reassemble all the segments back together according to the sequence numbers. And then you look at the port number, and if it's port number 25, you give it to your email server, the email protocol. All right, so that's okay, so that's that. Here is all the headers that are attached to the data that is given to you from the application layer. All right, so TCP is stateful. It keeps track of the state so it takes a look at all of these, the checksum, the reserve bit, there's the control bits. It keeps track of all of them. Here are the source and the destination port numbers that are also used. So all of these are labels that are placed on the data that is received from the application layer. So we call this whole thing a segment. So the application data is encapsulated into this segment. This whole segment then is given to the internet layer, the IP, and the IP will add more headers and it becomes a packet, right? All right, take a picture of this. This is good to know. I don't know if they're going to ask you about the specific of each label that is placed on the TCP header, but it's good to know at least to look at them and every once in a while. The user datagram protocol, on the other hand, because most likely it's usually used to transport data for directly connected devices within the LAN. It doesn't have to be connection oriented and reliable, because you're sending data right there to a device that is directly connected to you. So it's connectionless. It is not reliable. It's not going to check to make sure that the data is corrupted or not and ask for retransmission of the data from the source. So it's much, much quicker, right? There's no sequence numbers are placed. You just chop them up into segments, put the port numbers on them, and send them out. That's all UDP does. All right. So please take all these bullet points for UDP. So write that down as well. All right. So that's what user datagram, I think, best effort, right? So send the data and hopefully it gets there as quickly as possible. I said most likely within the LAN, but sometimes for real-time communications, people want to use, or devices want to use UDP for quickness. But the problem, there's no sequence numbers, there is no reliability, so other protocols have to come in and do that for them. But that's beyond the scope of this course to get into how UDP is being used in real-time communication, like for voice over IP or streaming video. We'll discuss that in another course. Look, it's much simpler. Look at all the labels on a UDP, right? Much less than the labels that are placed on a TCP segment. So a UDP segment is much quicker. It's stateless, which means it doesn't keep track of the state. It just sends out the data, doesn't keep track of it. All right, so take a picture of those. Those are the labels. As you can see, it's less. Again, good to know. I don't know how important you need to get into. To be honest with you, I don't think they do ask on the CCNA exams or even the CyberOps test the specific labels and how big they are and so on. But it's definitely good to know. Okay, socket pair. What is a socket? This is typically used. It is your IP address and the destination port that you are, or the source port that you are using, and the port number. So an you type in an IP address, 192.168.10, and you put a colon and you put a port number. These two together is what connects the device to a specific application, and this is called a socket. Socket pairs is the source and the destination port placed within the segment. Okay, so write the first bullet point. So there is your a TFT connection. There is the destination, port number 21, and then the source port. Okay, so it's typically written, let me see, where's the IP address? An IP address, and you put a colon, and you put that port number next to it. That's called a socket. Okay, so that's that. Now let's look at the session establishment. Each application running on the server is configured with a port number. So let's talk about these port numbers. So let's say this server is running an HTTP, a web server, and it's also takes data for the SMTP, the Simple Mail Transfer Protocol. So if this guy wants to send out email, he's going to send out port number 25 on his data. If this guy wants to access the web page, he's going to put port 80. So when the server receives the segments from both of these guys, this server is running an HTTP server and an SMTP server. So when he sees port number 25, he sends it to the SMTP. When he sees port 80, he sends it to the web page, right? The HTTP, because you can run two applications at the server. Now, when you respond back to the source port number that this guy did, and you respond back to the source number that as the destination. So when you send data back the server, it will use the source port as the destination, so the client knows when he sends it back. Okay, so that's how these requests. And this is all application. These port numbers are called well known, they are specific. So almost everyone that uses port number 25 knows that this data is for an email. Anybody that uses port 80, it's always known it's for HTTP. The source port number is dynamic. There's a pool of port numbers that you just pick up and use automatically. We can discuss this into class. There are three types of port numbers. There are the well-knowns from 0 to 1025. Then you have the reserved from 0 to 1023 is the well-known. From 1023 to 49,151 is reserved. People pay for it, in other words. From 49,152 to 64,000 is dynamic. You go into the dynamic and use any of those addresses as your source port address just so that the destination can respond back to you. All right, so that's what this is all is really discussing. Okay, now when we say TCP is connection oriented, that means you have to make a phone call. This is like you're trying to go to visit a friend who lives far away. If, let's say, 100 miles away. You're not going to get in your car and just go immediately. So what happened if he's not there? You just wasted your time driving up there. So it is best, what do? Make a phone call before you go. That means you make a connection. You call him and you say, hey, can I come over? In other words, can I send you data? And if he says no, you don't go. He's busy maybe. If he says yes, then you go. That's what connection establishment mean. That's why we say TCP is connection oriented. You send a sync signal to the destination. You make the phone call. Hey, are you there? And then the guy, your friend, will respond back with an acknowledgement. Say, yes, I'm here. You can come. And then you say, okay, I acknowledge your acknowledgement. This is called three-way handshaking. Okay? Those are the 3 steps. Before you start sending any segments, you have to create a connection. Is that clear? All right. How do you terminate? Once you send all the data to terminate the session, and you send the last one, and you tell the guy at the end, if it's successful, you send him another fin segment called the finish. So write this down. A fin segment is sent at the end of after the last segment. And you're telling them, if you check the last segment to the destination, you're telling the destination, if you check the last segment and it's successful, well, the fin tells them that that's it, we're closing the session. And that's what we do. Okay? So there's the fin. You acknowledge the fin and it's all over. And then the session ends. Okay? So you create a connection. Then after that, you send all your data. And when you're done, you send the fin and bingo, it's all over. That's the 3-way handshaking analysis. So please write down all of these, or you can take a snapshot of this if you want to. Okay, so this is what I've just discussed earlier. It establishes to make sure that the destination is present on the network and he's up and running and ready to go. Verifies that the destination device has an active service and is able to say, yes, I can process your data. It informs the destination device the source intends to establish communication, and so on. So this is very important because it does come up on the exams. This is specifically for TCP. UDP does not do this, by the way. It does not do the 3-way handshaking. Only TCP does that. And this is where all the control bits for this handshaking occur when you're communicating between the source and the destination. You're actually sending segments with control bits in there, and that's how you communicate with the other device using these control signals, those 3 handshaking signals. All right, so there is a good video on there in your book, in your ebook, so make sure you watch it. We'll do some labs with it. Let's look at the reliability now. What do we mean by TCP is reliable? Remember, we're specifically talking about TCP, not UDP. UDP is connectionless, doesn't do the 3-way handshaking, and is unreliable. So what we're discussing now, we are discussing specifically um, TCP. Okay, so when we say reliable, this is what we're going to do. So let's say you got the 10 segments. Just listen to what I'm saying, so this way you'll understand exactly what we're going to do. This is how TCP works. He grabs the data from the application layer, breaks it up into smaller segments, places sequence numbers on each one of them. Let's see, segment number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and puts port number. Let's say it's an email, puts port number 25 on each of them. All right, so the segments are ready, and the sequence numbers and the port numbers are stamped on all of those 10 segments, and he's ready to send them out. The first thing he do, TCP is connection oriented, so he sends out a sync signal to the destination telling them, hey, I want to send you data. That's sync 1. The destination acknowledges, and it says, yes, I'm ready, I can take it, and can take your data. And then the source will send them back. He says, okay, so I acknowledge your acknowledgement that you are ready to process the data that I'm going to send you. That's what connection-oriented mean. That's why we say we're creating a connection establishment. So once the connection is established, then I send them the first segment. The one has sequence number 1. I just send them 1, and I wait for the destination to send me back an acknowledgement that he has received segment number 1, that has sequence number 1, and was successful. So let's say he checked it out, the destination, and he says, okay, it's good. He sends me back a window, a segment, a control segment, saying that, okay, segment number 1 was good, and please send me 3 more. The window size will indicate 2. That means start with number 2 and send me 3 more, right? So 3 more segments. This is, the sequence number 3, window number 3. So window means send me 3 more starting with number 2. That means number 1 is good. So I'll send him number 2, 3, and 4 and wait for his acknowledgement. So he'll say, hey, very good, everything's good. Number 2, 3, and 4 segments were good. So he'll send me back and he'll tell me segment number 1, 2, 3, and 4 now are all good. He will say window 5 and segment and sequence 5. What does that mean? Segment 5, window 5, when I receive a message from the destination saying that window is 5, that means he wants 5 segments to be sent at the same time. Sequence 5 indicates to me start with number 5. That means I don't have to repeat number 4. So I'll send them 5, 6, 7, 8, 9. Those are the, right? 5, 6, 7, 8, and 9. Those are the 5 next segments. When I send them to him, let's say number 8 was corrupted, right? So he's going to send back to me and say, he's going to reduce the window to 3. And he's going to say sequence number 8. So that means 1 to 7 is good. We ignore 9. So I'll send them just 3 more because I see that the window has been reduced to 3. 3 more starting with number 8. So I'll send them 8, 9, and 10. And I know number 10 is the last one, so I will also send him a FIN, F-I-N segment. So if he receives the 3 and he processes them and they're all successful, then he receives the FIN. That means the session has been terminated. We terminate the session after that. Is that clear? That's how we call windowing. And that's how TCP controls the transmission of the data. That's why we call it transmission control. We're going to make sure all the data that's been received are successful. Sometimes if there's a lot of traffic and there is a lot of corruption and there is a lot of collisions on the way to the destinations, or some packets have got lost, you're going to have to retransmit, and that slows down. Once everybody is there at the destination and they are successful, then the destination will reassemble the data and give it to the appropriate protocol if it's protocol number 25, which is the email server. So, just a quick review. TCP is connection oriented. That means he does the three-way handshaking before he sends any data out. Reliable. It's going to make sure that the data is received successfully. Flow control using the windowing technique. So the destination is constantly telling the source to either increase or decrease the amount of data that's need to be transmitted, right? So connection oriented, reliable, with flow control. That's what TCP does, which is really nice. But it's slow, unfortunately. And there's a good video on it. Okay, so that's where the sequence number, I'd explain it to you. This is what I was talking about. Hopefully we try to review what I just said if that doesn't come out. So the window size and the acknowledgement. Remember, the window size is what the destination tells you to increase the amount of segments that needs to be sent. You can either increase it or decrease it. Okay, sometimes we call that sliding windows. Okay, so please write the first 2 bullet points for flow control. That's how we control the flow of data. By the destination telling us to either increase the amount of segments to be sent or reduce. And I have to wait for that, for him to tell me that. Okay, so that's what that is. All right, so we explained all of that. There is minimum size, maximum size. So we need to worry about that. Congestion avoidance. When congestion occurs on the network, it will result in packets to be discarded and overloaded on the router. So when packets containing TCP segments don't reach it, they are left unacknowledged. So that's important to know. By determining the rate of TCP segments, so this is important when we're doing trafficking. When determining the rate of TCP segments are sent but not acknowledged, the source can assume a certain level of network congestion, and you can do something about it, either slow down or increase the amount of data that need to be sent. Okay? So write down you can take a picture of all of this. This is an important slide that you should know for controlling avoidance. All right, so the labs we will take care of, and that ends the chapter. All right, we will do some labs and get into this. This is, again, a review of your CCNA 1 course. So hopefully this will refresh your memory. And so please take all the notes that I asked you to do, and I will see you in Module 10.